Welcome to clickmyproject.com. Our product title is a novel 3-phase current source rectifier with delta type input connection to reduce the device conduction loss. Next, we see about abstract of our product. In this proposed work, we design a new topology rectifier. That name is delta type current source rectifier. This design provides less conduction loss. This rectifier control signal is provided from space vector pulse width modulation technique in order to increase inrush current limiting capability and also reduce filter size. The proposed rectifier has delta type connection on its AC input side, and its DC link current can be shared by multiple devices at a given time. The main feature of this design is provide a step down AC to DC voltage converter function. It has been applied as the active front end in high efficiency power supplies for telecommunication and data centers. It can also be used as the off-board DC fast charger for electric vehicles to increase efficiency. In high power applications such as DC arc furnace and induction melting, this kind of rectifier are used. The delta type current source rectifier can largely reduce the size, loss and cost of the transformer and harmonic filters. For a variable speed motor type application, this kind of current source rectifier is used. It have lighter input electromagnetic interference filter compared with the traditional two-level voltage source rectifier. The performance of this delta type current source rectifier has been tested by computer-based simulation. Step up is developed and results are verified. Simulations are done in MATLAB. Next, we see about flow diagram of our product. Globally, the AC source is available in this work. The input source is an 3-phase AC voltage source. 3-phase power system achieve their higher conductor efficiency and lower safety risk by splitting up the total voltage into lesser parts and powering multiple loads at those lesser voltages while drawing currents at levels typical of a full voltage system. This technique, by the way, works just as well for DC power system as it does for single base AC system. Such systems are usually referred to as 3-wire systems rather than split base because base it is a concept restricted to AC. This is our flow diagram. Here this is a input AC source. That input AC source is fed into the input filter. Input filter is nothing but the reduce the harmonics in the input voltage side. Generally the filter is used to eliminate the harmonics, noise and unwanted signal in the desired signal. The input filters is nothing but here the input source is AC, so the input filter is AC filters. This design consists 2 filters, one in input side, another one in connected in output side. The output side connected is called as DC filter. We have learnt in rectifier circuits about converting a sinusoidal AC voltage into its corresponding pulsating DC. Apart from the DC component, this pulsating DC voltage will have unwanted AC components like the components of its supply frequency along with its harmonics. Next, after that, supply voltage is fed into the current source rectifier with delta type input side. Delta type is connected in the input AC source type, and the current source rectifier is converted AC to DC with respect to space vector pulse width modulation pulses. Okay, the 3-base bridge rectifier circuit has 3 legs, each base connected to one of the 3 base voltages. Alternatively, it can be seen that the bridge circuit has 2 halves, and the positive half consisting of SCRs S1, S3 and S5, and the negative half consisting of the SCR S2, S4 and S6. At any time when there is current flow, 1 SCR from each of conducts. And next one, the output is fed into the DC filter. So the output of the current source rectifier is the DC. So the DC voltages is filtered in the DC filter, and the DC filter output is fed into the load. The load is a R load, or inductive load, or capacitive load. Here we using R load. So the overall process is done in these blocks. Next, we see about running process of our product. In this proposed work, we design a delta type current source rectifier. Generally, we know that rectifier is converting AC to DC supply, and using of current source rectifier is nothing but it reduces the conduction loss over the traditional converters topologies. And using of delta type current source rectifier is nothing but the input AC source is connected in a delta connected. Generally we know that the AC supply is connected in two way. First one is star connection, another one delta connection. In this proposed work, the input source is connected in delta type. So this type of design is called delta type current source rectifier. In this work is done in MATLAB 2013 version. First open the MATLAB window, and next open the new model window. So next open the new model window. Now the window is open. Here the various blocks for our requirement. In this circuit diagram we using rectifier circuits and input AC source, filters and load. So we record capacitor, resistance and input AC source and ground, and also the converting switching power devices such as MOSFET, IGBT for our requirement. Those elements are in Simulink library browser. As per the circuit diagram, we created the blocks. After that we click the simulation run. After clicking the run symbol, then the output window is open in the corresponding scopes. First one is input current waveform, 3-base input current waveform, and this waveform is only one base. Next one, this is the input voltage waveform for 3 bases A, B, C, and next one is input pulses alpha value, and next this is the corresponding pulses for our record 6 switches. And next one, the output voltage. The first one is output voltage, that range is 120 to 190 something, and next one is 36 to 39 around the output current. This is the input 3-base current waveform. So using a delta type current source rectifier, it provide conduction losses and less filtering size, and also it provide a higher efficiency compared to the traditional converters.